So let's start from the first integral. The first integral states that integrate x to the power 4 minus 2x squared plus 5 dx. So if this is in a polynomial form, you can just integrate it one by one. So first integrate this, then this, then this. So the answer is x to the power 5 by 5 plus minus 2/3 x cube plus 5x plus c. So now let's proceed for the second integral. So the second integral is integral 5 to the power 2x dx. So this is in a general format. So the general format is a to the power mx dx integral, which is a to the power mx by m times log a plus c. So this is in a general format. So we can just integrate it simply is 5 to the power 2x by 2 times log 5 plus c. So this is the second integral. Now let's proceed for the third one. So the third one is integral e to the power x log a plus e to the power a log x dx. So from properties of log, this x will go to the power and this a will go to the power as well. So this becomes e to the power e log e a to the power x plus e to the power log x base log x to the power a base e dx. So from properties of log, you can just again say that this will cancel out and a to the power x plus x to the power x dx will be integrand. So this will be a to the power x plus x to the power a dx, and we can just simply integrate this as a to the power x by log a plus x to the power a plus 1 by a plus 1 plus c. So this is our final answer for the third question. So let's proceed for the fourth one, which is integral cos x degree dx. So now it is in degree. So as you all know that cos theta d theta integral is sine theta, but this happens when that theta is in radians. So in this case, as this theta is in degrees, we have to transfer this in radians. So pi radian is equals to 180 degree, implies x degree is equals to x pi by 180 radian. So you can just put it here, will give us cos x pi by 180 dx, and this is like m, this quantity. So this is actually sine x pi by 180 divided by pi by 180 plus c, which is 180 by pi times sine, this is again x degree plus c. So this is our answer for the fourth question. So should I erase this? I hope so. Let's erase this. So now let's proceed for the fifth question, which is now let's proceed for the fifth question, which is integral 1 plus tan square x by 1 plus cot square x dx. So just simply make this sine square x by cos square x, and this will give us cos square x plus sine square x by cos square x by cos square x by cos square x plus sine square x by sine square x dx. So this just cancels out, and this is cos square, this sine square x will go on the top, so this will become tan square x. So this is integral tan square x dx, which can be written as x square x minus 1 dx And as you know that integral of sec squared x is 10x and integral of minus 1 is minus x. So this can be written as 10x minus x plus c. So this is our answer for the fifth integral. So let's proceed for the sixth one. So for the sixth integral we have integral x to the power 6 minus 1 by x minus 1 dx. So x to the power n minus 1 is always divisible by x minus 1. So we can just synthetically divide it. So what synthetic division is, let me tell you that 1 0 0 0 x to the power 6 5 4 3 2 1 minus 1 and 1. So the first will go down, then you have to multiply it and write it here and then add them. So 1 1 1 1 1 1 1 1 1 and this will become 1 and this will become 0. So as this portion is 0, so there is no remainder. There is no remainder and this is our answer. So the answer is x to the power 5 times x to the power 4 plus x cubed plus x squared plus x plus 1. So this is our answer. So this can be simply written as integral x to the power 5 plus x to the power 4 plus x cubed plus x squared plus x plus 1 dx, which can be written as x to the power 6 by 6 plus x to the power 5 by 5 plus x to the power 4 by 4 plus x cubed by 3 plus x squared by 2 plus x plus c. So this is the answer of the sixth integral. Now let's proceed for the seventh one. Now let's proceed for the seventh one. The seventh integral is integral cos cube x dx, which is integral 1 minus sine squared x times cos x dx. So I have made the cos square x as 1 minus sine square x because I am willing to take the sine x as u. So then the cos x dx will become du. So we can just write it as take u is equal to sine x implies du is equal to cos x dx. So this becomes 1 minus u squared du and this is actually u minus u cubed by 3 plus c, and let's put it original variable sin x minus sin cube x by 3 plus c. So this is our answer for the seventh question. Now let's proceed for the eighth question. So the eighth question is, what is the eighth question? Integral cos x plus sin x, integral cos x plus sin x divided by cos x minus sin x times 1 minus sin 2x dx. So there is a little note which is this. So let's simplify this as 1 minus sin 2x can be written as 1 can be written as cos square x plus sin squared x, and sin 2x can be written as minus 2 sin x cos x. So this can be written as cos x minus sin x whole square. So I am willing to put that there. So I am willing to put that there. So the integral becomes integral cos x plus sin x divided by cos x divided by cos x minus sin x times cos x minus sin x whole squared dx. So cut one, and this is actually a plus b times a minus b, which is a square minus b square. That means this will become cos square x minus sin squared x, and cos square x minus sin squared x can be written as cos 2x. So this can be written as cos 2x dx, which can be integrated as sin 2x by 2 plus c. So this is our final answer for the 8th question. Now let's proceed for the 9th question. So the 9th question is question number 9, which is integral dx divided by sin square x cos square x. So this can be done in many methods. Which I am going to use is multiply 4 and divide by 4. So multiplying 4 times dx by dividing 4, we can write 4 as 2 square. So this whole quantity becomes 2 sin x cos x whole squared. Okay, so as this is 2 sin x cos x whole squared, we can write it as integral dx by sin squared 2x, because this is sin 2x and this is sin 2x squared. So that means this can be written as 4 times cos x squared 2x dx, and this is a standard integral, which is 4 times minus cot 2x by 2 plus 3. Let's simplify. It is minus 2 cot 2x plus c. So this is the answer for the 9th question. So now let's proceed for the 10th question, which is, now let's proceed for the 10th question. This one is not perfect. Now the 10th question. So the 10th question is integral tan inverse sin x by 1 minus cos x dx. So for this question, what we have to do is we have to write this as a function of tan, so that we can cancel the tan inverse and tan. So let's try to write it as function of tan first. So let's do that here. So this is sin x by 1 minus cos x. Sin x can be written as 2 sin x by 2 cos x by 2, and 1 minus cos x can be written as 2 sin squared x by 2, because cos 2x is equals to 1 minus 2 sin squared x. So here x, here 2x is x, and so x is x by 2, and you can just change the side, that is 2 sin squared x is equal to 1 minus cos 2x. So cut them out, cancel them out as well. So this will give you cot x by 2, which is actually tan pi by 2 minus x by 2. So we have written that as a function of tan. So now we can proceed as, just remove this. Now we can just proceed generally as, this is integral tan inverse of tan, this is pi by 2 minus x by 2 dx. This is actually integral pi by 2 minus x by 2 dx, which actually gives pi x by 2 minus x squared by 4 plus c. So this is the answer for the 10th integral. So now let's proceed for the 11th integral, which is, so just remove this portion. So let's proceed for the 11th integral. So the 11th integral is integral dx by 1 minus cos x. So what we can do here is integral dx by, this becomes 1 minus Can we do it in any other manner? I hope so. So don't do it. Do like 1 plus cos x divided by 1 plus cos x times 1 minus cos x, which is 1 minus cos square x. So that becomes sine square x. So let's write it as sine squared x dx and then split them up. So this becomes integral of cosec square x, and this becomes integral of, where is dx here? And this becomes integral of cosec x cot x dx. So this is actually minus cot x, and this is actually minus cosec x plus c. So this is our answer for the 11th integral. So now let's proceed for the 12th integral, which is, let's remove this. So now let's proceed for the 12th integral, which is integral of cos 2x cos 4x dx. So for this integral I am going to do multiply and divide by 2, which is 2 cos 2x cos 4x dx. Let's write it clearly. So this can be written as integral 2 cos 2x plus cos 4x can be written as cos a plus b plus cos a minus b, which is actually integral cos a plus b is cos 6x plus cos a minus b is cos 2x dx. So we can just simply integrate this as half sine 6x by 6 plus sine 2x by 2 dx. So plus c. So this is the answer for the 12th question. So now let's proceed for the 13th one, which is actually 13th one is, so the 13th question is integral sine of mx sine of nx dx. So we can again we can again multiply and divide by 2, which is 2 sine mx sine nx dx, and this is, well, here is the condition, which is m not equal to n. So yeah, this can be written as integral cos mx minus nx minus cos mx plus nx dx, which is actually half integral. So this is actually m minus n times x. So this can be written as, so after integrating, this will become sine m minus nx by m minus n minus sine m plus nx by m plus n. So this plus c. So this is the answer for the 13th integral. And now let's proceed for the 14th one, which is, let's proceed for the 14th one, which is integral e to the power x sin x plus cos x dx. So this can be written as integral e to the power x sin x plus e to the power x cos x dx. So if you can see that if you take e to the power x sin x as z and then take the differential of both sides, which is e to the power x sin x is equals to dz, it will give you that e to the power x is constant, then sin x will become cos x, that means e to the power x cos x, plus when sin x is constant, then e to the power x will differentiate in e to the power x. So this becomes e to the power x sin x plus e to the power x cos x times dx is equals to dz. So that means we don't have to substitute, actually we can just put this in this total thing. So this becomes integral of d e to the power x sin x. So this is e to the power x sin x plus c. So this is our answer for the 14th integral. Now let's proceed for the 15th one. Now let's proceed for the 15th one, which is now let's proceed for the 15th one, which is integral of x squared dx by 2 plus x cubed. So in this case you can just take this as u, so put 2 plus x cube is equal to u, and this will give 3x squared is equal 3x squared dx is equal to du, and x squared dx is equal to du by 3. So the integral will become 1/3 integral of du by u, that is 1/3 ln u plus c, which is actually 1/3. Take the ln, which is substituted in the original variable, which is ln of 2 plus x cube plus 3. So this is the answer for the 15th question. Now let's proceed for the 16th one. So the 16th question is, integral x divided by root x plus 1 dx. So for this question, put x is equal to z squared. Okay, so the denominator will become z plus 1, and let's differentiate this as dx is equal to 2z dz. So x dx will become 2z cube dz, because we are multiplying x in this side and z square in this side, because both are actually identical. So this becomes integral 2z cube dz by x plus 1. So we can just take the 2 out. Z cube plus 1 minus 1, well, there is the integration, sorry. So this is actually 2 times integral z cube plus 1 minus 1 dz by z plus 1. So why I am actually doing this, because well, there is a note as well again. So the note is z cube plus 1 can be written as z plus 1 times z square minus z plus 1. So if we split this up, this will become only this portion. So just put it up and I have the answer, which is 2 integral z square minus z plus 1 minus 1 by z plus 1 dz, which is 2 times z cube by 3 minus z square by 2 plus z minus ln z plus 1 plus c, which is actually 2/3. So z is actually x to the power half, so z cube is actually x to the power 3 by 2 minus this is actually x, because 2 and 2 will get cancelled, and this is actually plus 2 times x to the power half minus ln z is actually root x plus 1 plus c. So this is the final answer for the 16th question. Now let's proceed for the 17th question, which is actually, well, let's proceed for the 17th question. So the 17th question is, well, sorry. So the 17th question is integral x squared plus 1 dx by x plus 1 whole squared. So yeah, we can just integrate it as x squared plus 2x plus 1 minus 2x by x plus 1 whole squared dx. So this is actually x plus 1 whole squared by x plus 1 whole squared. This is going to cancel out, it will become 1 minus this is 2x by x plus 1 squared dx. So we have to integrate this. So this becomes x, this portion 1 becomes x, and to integrate this I'm going to take 2 outside, and x plus 1 minus 1 by x plus 1 whole square dx. So this is x minus 2 times, just split it up, becomes integral 1 by x plus 1 dx minus the minus is also here, so this is actually integral dx by x plus 1 whole squared. Okay, so we can just write it as x minus, so this is 2 times, this is ln x plus 1, and this is actually plus 1 by x plus 1 plus c. Why this is plus? Because minus 2, a minus will come out of this, and this makes it plus. So you can just elaborate the minus, or this is the final answer. So let's write it as this is the final answer. So now let's proceed for the 18th question, which is now let's proceed for the 18th question. So the 18th question is integral dx divided by x root under x squared minus a squared. So for this particular question I am going to take x as a times sec theta, because I can just take the a squared out and then it will become sec squared theta minus 1, which eventually becomes tan squared theta, and here is the root, so that becomes tan theta. So I am going to take x as a times sec theta, and so dx will becomes a sec theta tan theta d theta, and this becomes integral a sec theta tan theta d theta divided by a sec theta, and this becomes a square tan square theta under root, so this is actually a times tan theta. So you can just cut them out, and 1, so this is 1 by a integral d theta. So this is actually 1 by a theta plus c, and 1 by a theta is actually sec inverse x by a. So theta is actually sec inverse x by a plus c. So this is the answer for the 18th question. Now let's proceed for the 19th one. So the 19th question is the 19th question, I have to turn the page. So for 19th question, question number 19 is integral sin x dx divided by sine of x minus a. So I am going to write x as sine of x minus a plus a dx divided by sine of x minus a. I have written this as this because I want to split this up into sine a plus b formula, which is going to be integral sine x minus a cos a plus cos x minus a is sin a divided by sine of x minus a dx. So then just split them up. This sin x minus a and this sin x minus a will cancel each other. This cos a is constant, so this will get out of the integration. So this is cos a integral dx, and here sin a is constant, so sin a will get out of the integration, and this will become cot x minus a. So sin a is out of the integration, and this will become cot of x minus a dx. So for this portion, this is x cos a, and this is actually log of sine of x minus a. So this becomes log of sine of x minus a times sine a plus c. So this is the 19th question. So now let's proceed for the 20th question, which is 20th question. Oh, let's remove this one. Now let's proceed for the 20th question, which is 20, which is integral x times e to the power x dx. This is dx divided by x plus 1 whole squared. So you can write x as x plus 1 minus 1 times e to the power x divided by x plus 1 whole squared dx. Now split them up, which gives you e to the power x by x plus 1 dx. Sorry, not equal to, minus integral e to the power x by x plus 1 whole squared dx. Now put this, let's see what this comes. I don't know, this will become, so this is e to the power x by x plus 1. Let's do it at dx. So dx will give so this is that this dz, and this is actually e to the minus 1 by x plus 1 squared plus e to the power x by x plus 1 whole squared. Sorry, x plus 1 and is it correct? Well, I hope I need some more space maybe. Yeah, this is minus portion. This is the positive portion. So yeah, I hope substituting this will do our job. So let's substitute this. So let's suppose e to the power x by x plus 1 is equals to z. So when we take the dz, this will become e to the power x by what is the ddx of this? This ddx of this is x plus 1 whole squared minus, because minus 1, yeah. This is minus of e to the power x by x plus 1 whole squared plus e to the power x by x plus 1 dx is equals to dz. So this becomes, now this e to the power x dx by x plus 1 minus e to the power x dx by x plus 1 whole square is equals to dz. Okay, so this is actually the same format, so we can just write it as dx here, and this is actually the ddx of this format. So this is actually d of e to the power x by x plus 1. So the answer is e to the power x by x plus 1 plus c. So this is our final answer for the 20th question. So now let's proceed for the 21st question, which is let's erase this one. Let's proceed for the 21st question, which is actually what is this? This is 21st question. So this is x times root under x squared plus 1 dx. So for this question I am going to take x is equal to tan theta. The reason is that 1 plus tan squared theta will become sec squared theta and the root will cancel that. So that will become only sec theta. So put x is equals to tan theta. Now dx will become sec squared theta d theta. So this becomes this becomes tan theta times x equals to tan theta. So dx is equals to sec squared theta d theta. So this is sec squared. So this is actually sec theta times sec squared theta d theta. So now let's just assume that sec theta is equals to u. So assuming sec theta is equal to u, so this portion will become du. So this whole portion will become du. So assume that sec theta is equals to u. So sec theta times theta d theta will become du, and your integration becomes u squared du. So this is actually u cube by 3 plus c. U cube by 3 plus c. Now first change the second variable, which is sec cube theta by 3 plus c, and theta was tan inverse x. So actually this is sec of tan inverse x by 3, this portion whole cube plus c. So now as tan theta is equal to x, now there is a simple note here, which is as tan theta is equals to x, so sec theta is 1 plus x squared the root. So theta can be also written as root under 1 sec inverse root under 1 plus x squared. So this tan inverse x can also be written as sec inverse root under 1 plus x squared. So that sec and this that sec inverse and this sec cancels each other, and this is only remains. So this can also be written as 1 plus x squared times 3 by 2 by 3 plus c. So this is our final answer for the 21st question. Now let's proceed for the 22nd question, which is let's erase this portion. I hope this is clear to all of you. So now let's proceed for the 22nd question, which is integral e to the power 2 minus 3x dx. So for this integral, what we can do is we can just take out e squared first, because e squared is a constant. So just take out e squared first, and this is e to the power minus 3x dx, and this is the standard integral, which is e squared times e to the power minus 3x by minus 3 plus c, which is actually minus 1/3 e to the power 2 minus 3x plus c. So this is the answer of the 22nd question. So now let's proceed for the 23rd question, which is integral of cos of log x by x dx. So for this integral, I am going to assume that log x is equal to u. So dx by x is du, and this portion becomes du, and this portion becomes cos u. So this is actually integral cos u du, which is sine u plus c, and u was log x, so this is actually sine of log x plus c. So this is the answer of the 23rd integral. Now let's proceed for the 24th integral. Now the 24th integral, here it comes. So 24th integral is integral 1 minus sine x divided by root under x plus cos x, x plus cos x dx. So as you can see that x plus cos x, if we differentiate this one, we get this. So this can be written as, just first take this as u. So x plus cos x is equals to u. Now differentiate both sides. So this becomes 1 minus sine x dx is equals to du. So let's take it u square. So we don't have to deal with any loop in the integral portion. So this becomes 2u du. So this becomes integral 2u du by u. So u and u gets cancelled. So 2 integral du. So 2u plus c, and u actually is the root over of this portion. So this is actually 2 root under x plus cos x plus c. So this is the answer for the 24th integral. Now let's proceed for the 25th integral. So let's erase this. Let's proceed for the 25th integral. So 25th integral is integral x dx by sine squared x squared. So for this integral, just put x squared as u. So write x squared is equal to u. So this becomes 2x dx as du. So x dx is becomes du by 2. So this is actually half integral du by sine squared du. So half integral, this is cosec squared u du. So cosec squared u du. So this is half times minus cot u plus c. So this is minus cot, what was u? U was x squared. So minus cot x squared by 2 plus c. So this is our answer for the 25th integral. So let's proceed for the 26th integral. The 26th integral states, the 26th integral is what is this? The 26th integral is integral tan x sec squared x dx divided by root under a squared plus b squared tan squared x. Yeah, this is the 26th integral. So if we take this as u squared, so let me do it like this. So take a squared plus b squared tan squared x as u squared. So this becomes b this b squared is constant. This 2b squared times tan x times sec squared x dx is equals to 2u du. 2 gets cancelled, and this becomes tan x sec squared x dx is equals to u du by b squared. So just put that in our original equation. We get this becomes 1 by b squared integral u du by u. So u and u gets cancelled, which is 1 by b squared times u plus c, and u was 1 by b squared root under a square plus b square tan square x plus c. So this is our answer for the 26th integral. Now let's proceed for the 27th integral. So I hope you understood this one, because a and b are constant, so a square, differential of a square is 0 and differential of b square cannot be differentiated, so it comes out of the differentiation. I hope you understand this. So yeah, I hope it's correct. Now let's proceed for the 27th integration. So the 27th integration is so the 27th integration is integral x minus a by x plus a dx, and this can be written as x plus a minus 2a by x plus a dx, and this is actually integral dx minus 2a integral dx by x plus a, sorry, this is x plus a, and this is actually x minus 2a ln x plus a plus c. So this is the answer for the 27th integral. Now let's proceed for the 28th integral, which is integral e to the power 2x dx by e to the power x plus 1. So let's let's in second step, let's write it as e to the power x times e to the power x dx by e to the power x plus 1. Okay, so now this e to the power x plus 1, write e to the power x plus 1 as u, so e to the power x dx becomes du, and e to the power x becomes u minus 1. So put them back, is this becomes du and this becomes u minus 1, so u minus 1 times du by u. So this is actually integral du minus integral 1 by u du, which is u minus ln u plus c. So I should just erase this one, otherwise I cannot just proceed. So our u was e to the power x plus 1. So u was e to the power x plus 1, so e to the power x plus 1 ln u, so minus ln e to the power x plus 1 plus c, so write it as c dash. So like e to the power x minus ln e to the power x plus 1 plus c, so where c is equals to c dash plus 1. So because 1 is constant, we put that in the integration constant. Okay, because 1 is constant. Now let us proceed for the 29th question. So let's go for the 29th question, which is which is 29th question is integral dx by root x times root x plus, sorry, this is integral dx by x plus root x. So what we can do is, we can just take the dx by root x common, and this will become root x plus 1. So now take this as u. So root x plus 1 is equal to u. This becomes 1 by 2 root x is equals dx by 1 by 2 root x is equals to du, and dx is equals dx by root x is equals to 2 du. So this becomes integral 2 du by u. So this is 2 ln u plus c, and this is 2 ln, what was our u? U was root under x plus 1 plus c. So this is our answer for the 29th question. So now let's proceed for the 30th question. So the 30th question is, now the 30th question is sin x times sin of cos x dx. Oh, sorry, 10. So this is actually if you if you differentiate cos of cos x, what will it give? This will give sin of cos x, sorry, minus sin of cos x times differential of the interior will give times minus sin x dx. Okay, so this becomes sin x times sin of cos x, okay, dx. So this can be written as differential of this. So we can write it as differential of cos of cos x. So integrating a differential will give us this, and this is cos of cos x plus c. So this is the 30th question. Now let's proceed for the 31st. Let's proceed for the 31st question, which is integral 2x minus 5 times root under 2x plus 1 dx. So what we can do, let's proceed by assuming this as z. Okay, so 2x plus 1 is equal to z squared becomes 2dx is equals to 2z dz. 2 will cut 2, and this is dx is equals to z dz. Okay, and now from here we can substitute this as, if 2x plus 1 is equal to z square, then 2x minus 5 is equals to z square minus 6. So this integration can be written as z square minus 6 times z times z dz. So this is actually z to the power 4 minus 6 z square dz integral. So this is z to the power 5 by 5 minus 6 z cube by 3 plus c, which is z to the power 5 by 5 minus 2z cube plus 3. So z is root under this, so this becomes 2x plus 1 to the power 5 by 2 by 5 minus 2 times 2x plus 1 to the power 3 by 2 plus c. So this is our answer for the 31st integral. So now let's proceed for the 32nd integral, which is, let's just remove this one. So let's proceed for the 32nd integral, which is integral x plus 1 by x times x plus log x squared dx. So this can be written as 1 plus 1 by x times x plus log x squared dx. So if you take this as u, this as u, so x plus log x as u, so 1 plus 1 by x dx will become du. So this portion becomes du, and this is u squared, so u squared du. So this is u cubed by 3 plus c, and u was x plus log x, so x plus log x cubed by 3 plus c. This is the answer for the 32nd question. So now let's proceed for the 33rd question, which is actually 33. Let's do this here. Now let's do the 33rd question, which is integral dx by 1 plus e to the 1 plus e to the power x, which is 1 by e to the power x times e to the power x dx by 1 plus e to the power x. Now you can just assume this as z. So 1 plus e to the power x is z, so e to the power x dx is equals to dz. So this becomes dz, and this e to the power x will become z minus 1 times z. So you can just write it as z minus 1 times dz by z times z minus 1. So you can just split it up as, so you can just split it up as integral of dz by z minus 1 minus integral of dz by z. So this becomes ln z minus 1 minus ln z plus c. So z minus 1 is e to the power x, so this is ln e to the power x minus ln this is 1 plus e to the power x plus c. So this is actually ln of e to the power x is equals to only x, so x minus ln of 1 plus e to the power x plus c. So this is our final answer for the 33rd question. Now let's proceed for the 34th question. So the 34th, right? Yeah, let's write it in the bottom. So this is actually x minus ln of 1 plus e to the power x plus c. So now let's go for the 34th question, which is, now let's go for the 34th question, which is actually, what is this? This is integral e to the power x times log of sec x plus tan x plus sec x dx. So this is another simple integration. So this is another simple integration because this is actually, if you take e to the power x times sec x as z, and wait, no, this is going to work like that. This is integral of, nah, this is not going to work like that. So what we can do, this is not going to work like that, so let's just what we can do, we can just, no, this is not differential of sec. Actually this is the integration of sec x. Yeah, so let's try integrating by parts. I don't know if this is going to be correct. Well, let's just try integrating this by parts. So our first, am I going to, okay, oh, okay, don't touch this part. So just divide it in two parts. So this is e to the power x sec x dx. Now don't touch this one. Let's just integrate this one separately. E to the power x sec x dx will give the, what do you take? Take this as the second function. Okay. Take this as the, what do you take this as first or second? Take this as second function. So this is e to the power x integral sec x dx minus integral of dvx of e to the power x times integral sec x dx of dx. Okay. So now this can be written as e to the power x times integral of sec x is ln of sec x plus tan x, and this is going to be minus of integral dx of e to the power x is only e to the power x, and this is actually log e. This is actually ln of sec x plus tan x dx. So when you add them both, this will cancel out with this one. So the answer can be, we can just simply write the answer as integral. So from here we take the arrow here and let's write it in a different ink. Integral e to the power x log e sec x plus tan x sec x plus tan x plus e to the power x log e sec x plus tan x minus integral log e, sorry, minus e to the power x log e sec x plus tan x dx. So this will cancel out by this, and I am writing the answer here. So the answer is actually e to the power x log e. So the answer is e to the power x log e sec x plus tan x plus e. So this is the answer for our 34th question. So now let's proceed for the 35th question. So let's proceed for the 35th question now. So 35th question, right? The 35th question states integral root under, so x by a minus x dx. So what we can do is we can just substitute x is equals to a sine squared theta. Why? Because when we take out a from here, this will become 1 minus sine squared theta, and that will become cos squared theta, and the upper portion will become sine squared theta. So let's do it. Integral root under a times sine theta. Oh, sorry, we have to transfer the variable. So dx will become a times 2 sine theta cos theta d theta, which is actually, no, let's try. Let's leave it like that. So x is equals to a sine squared theta. So dx is equals to a times 2 sine theta cos theta d theta. So this is actually a times sine of 2 theta d theta. So this is actually a times sine of 2 theta d theta. Okay, so let's put it back, or rather we can just leave it like that. We don't have to do that. So this is 2 sine theta cos theta d theta, and here is another a which comes from here, and the lower portion will become root a times, this becomes 1 minus sine square theta. 1 minus sine square theta is cos square theta, and root under cos square theta is not. So this is sine root a times cos theta. Okay, so cancel them out as well. So take a outside, and this becomes 2 sine squared theta d theta. 2 sine squared theta can be written as 1 minus cos 2 theta. So this is integral 1 minus cos 2 theta. So this is actually a times theta minus sine 2 theta by 2. So this is actually what was our theta. So from here we can write theta as sine inverse root under x by a. Yeah. So theta can be written as sine inverse root under x by a minus, this is something ridiculous. Okay, we can just divide the 2 via the 2 which comes from the sine 2 theta, which is 2 sine theta cos theta, and this becomes minus sine theta cos theta. Okay, yes. So this is actually a times sine inverse root under x by a minus, what was our sine theta? The sine theta was root under x by a, and cos theta will be then well, sine squared theta plus cos squared theta is equals to 1. Hence, as our sine squared theta was x by a, so x by a plus cos squared theta is equals to 1. So cos squared theta is equals to a minus x by a, and cos theta will become root under a minus x by a. So this becomes root under a minus x by a plus c, and this is actually root a times root a, which is normally a, and this a will cancel out via this a. So this is a sine inverse root under x by a minus, this a gets cancelled out, root under ax minus x squared plus c. So this is our 35th question. Now let's proceed for the 36th question, which is, let's proceed for the 36th question. Yeah, this is the 36th question. So 36th question. So the 36th question is integral of e to the power x times 1 by x minus 1 by x squared dx. Okay. So let us split it up. 1 by e to the power x by x minus e to the power x by x squared times dx. Okay. E to the power x dx by x minus integral e to the power x dx by x squared. Now I apply by parts on this. So let's take this as first function and this as I'm telling something wrong. take this as this 1 by x as first function and e to the power x as second function. So this becomes 1 by x integral e to the power x dx minus integral of ddx of 1 by x times integral of e to the power x dx times dx minus integral of e to the power x dx by x squared. So this is actually e to the power x by x only, minus this will become minus 1 by x squared, and that minus will come out, this will become plus. So this is actually plus and this is e to the power x. So this is integral of e to the power x dx by x squared. So this is actually integral e to the power x dx by x squared. Okay, let's write it somewhere here. This is plus. So minus integral e to the power x dx by x squared. This and this gets cancelled out, and this is actually e to the power x plus by x plus c. So the answer of the 36th question is this. Now let's proceed for the 37th question, which is camera is still recording. Now let's proceed for the 37th question. So the 37th question is integral 1 plus tan x divided by 1 minus tan x dx. So for this question I am going to just split the tan into sine by cos. So let's do that. So let's do that as integral 1 plus sine x by cos x divided by 1 minus sine x by cos x dx. So the cos x gets cancelled out, and this leaves us with integral integral cos x plus sine x by cos x minus sine x dx. Now to let's differentiate this. Let's cos x minus sine x is equals to u. Okay, so minus sine x minus cos x dx is equals to du. So sine x plus cos x dx is equals to minus du. Okay, so we can just write it as minus integral of du by u. So this becomes minus ln of u, so plus c, minus ln of u was cos x minus sin x. So this is cos x minus sin x plus c. So this is our final answer for the 37th question. Now let's proceed for the 38th question, which is let's proceed for the 38th question. So wait, let me have some water first. So let's proceed for the 38th question. Well, can I just erase this one so that I may have some space? So the 38th question is here. So the 38th question is integral sin x cos cube x dx. Okay, so for integrating this I am going to factor this in cos square x and cos x. So this is actually integral root under sine x times cos square x times cos x cos x dx. So this is actually integral sine x. I can write it as 1 minus sine squared x, and this is 1 minus sine squared x, and this is cos x dx. So now I can put sine x is equals to u squared. Why I am putting u squared? Because I don't have to deal with root in the integration portion. So that means cos x dx is equals to 2u du. So this becomes u times 1 minus u to the power 4 times 2u du. Okay, and take the 2 out. This becomes u squared minus u to the power 6 d, because u squared, this with this will give u squared and u to the power 6. So this is actually 2 times u cubed by 3 minus u to the power 7 by 7 plus c. So u was root under sine x, so put that back. So this is sine x to the power 3 by 2 by 3 minus sine x to the power 7 by 2 by 7 plus c, and we can just, this is actually this is actually sine x times root under sine x, and this is actually sine cube x times root under sine x. So we can just take the root sine x outside. So this gives sine, this is 1 plus half, yeah. So this is sine x plus by 3 minus sine cube x by 7 plus c. So this is our 38th question. Let's proceed for the 39th one. So 39th one, here we come. So let's proceed for the 39th question. The 39th question is integral dx by cos 2x time, plus square root of 3 times sine 2x. Okay, so let's have by 2. Let's multiply and divide by 2, which is 2 times half cos 2x plus root 3 by 2 sine 2x. So let's take this 2 out. So this is half times dx by, this is actually sine 30 and this is actually cos 30. So we can write it as sine of 2x plus pi by 6. Okay, so this becomes half, let's integral cosec 2x plus pi by 6 dx, and that is half times ln of, this is actually, yeah, ln of 2x plus pi by 6 minus cot of, minus cot of 2x plus pi by 6 divided by 4 actually, because the 1 2 comes from here and 1 2 comes from here, so divided by 4 plus c. So this might be our final answer. If someone wants to rearrange it, they can, but this is actually the answer after integrating. Okay, so now let's proceed for the 40th question, which is let's proceed for the 40th question. Let's proceed for the 40th question, which is integral e to the power x by x, which is integral e to the power x by x times x log x plus 1 dx. Now what we can do with this? X gets cancelled out, 1 by x will come out from here. Yeah. Okay. So just separate this in parts, which gives e to the power x log x dx plus integral e to the power x by x dx. Okay. Now do this by parts and take the which portion first? Take the log as first function. So log x root under log x integral e to the power x dx minus integral dx of log x integral e to the power x dx plus integral e to the power x by x dx. Okay, so this is actually e to the power x log x, because integral of e to the power x dx is only e to the power x and multiplied by log x. This is actually 1 by x and this is e to the power x. So this is e to the power x by x dx plus integral e to the power x by x dx. So both of them cancels out and your final answer is e to the power x log x plus c. So this is our 40th integral. Let's proceed for the 41th. So our 41 integral is, let's take the pen. So our 41 integral is integral dx by root under 1 plus sin x. So this is actually, you have to write 1 plus sin x in a whole square format, which is actually dx by 1 plus sin x is equals to cos square x by 2 plus 2 sin x by 2 cos x by 2 plus sin squared x by 2, which gives you cos x by 2 plus sin x by 2 squared, and as here is a root here, so the square will cancel out. So this is actually dx by cos x by 2, dx by cos x by 2 plus sin x by 2. Okay, now let's just take 1 by root 2 outside, and this is in box. This is not in the equation, so this is in box. So now let's take 1 by root 2 outside, and dx by 1 by root 2 cos x by 2 plus 1 by root 2 sin x by 2. Okay, so this is 1 by root 2, this is 1 by root 2 integral dx of, this is actually sin x by 2 plus pi by 4. Okay, so this is 1 by root 2. Time takes time. Let's take cos now. Let's take cos. So if I take cos here, so this is actually cos pi by 4 times cos x by 2 plus sin pi by 4 times sin x by 2. So this will become cos x by 2 minus pi by 4. Okay, so integral of sec x by 2 minus pi by 4 dx. So this is actually 1 by root 2 times log of sec x by 2 minus pi by 4 plus tan x by 2 minus pi by 4 plus c. So this is our final answer for the 41st question. Now let's proceed for the 42nd question, which is, so should I guess this one? So let's proceed for the 42nd question, which is what? Second, integral dx by root under 3 minus 5x minus 2x squared. Okay, so what now? We can do is take out, yeah, let's do it principle. So just step this okay, this way do it in a very lean manner, which is root under 3 by 2 minus 5 by 2x minus x squared. So 1 by root 2 integral dx divided by, so we have to write this in a whole square minus another whole square. So let's do that in some other place there. So this is actually 3 by 2 minus 5 by 2x minus x squared. So let's take 3 by 2 minus 2 times 5 by 4x minus x squared. So we have to write as this is negative, this cannot be negative, so we have to take another minus 25 by 16 here. Okay, why? Because adding 25 by 16 we are going to take the negative as common, and then this will form a whole square. So plus 3 by 2 plus 25 by 16. Okay, so this is actually 8 and 49. This is actually 49 by 16 minus x plus 5 by 4 whole square. Okay, so this is x plus 5 by 4 whole square because 2ab. Yeah, so let's write it as 49 by write it as that. Write it as 7 by 4 squared minus x plus 5 by 4 whole square. Okay, so let's erase this. So this becomes, this is the standard formula, which is what should I write this? Dx by root under a squared minus x squared. This is actually formula of sine inverse. This is actually sine inverse x by a. Okay, so this is 1 by root under 2 sine inverse x plus 5 by 4 by 7 by 4 plus c, which is 1 by root 2 sine inverse 4x plus 5 by 7 plus c. Okay, so this is the answer for the 42nd question. Now let's proceed for the 43rd question, which is let's proceed for the 43rd question, which is integral dx divided by root under, sorry, this is integral dx divided by root under x minus alpha times beta minus x. So what we can do here, we can just write it as a mathematical, or otherwise we can take this form any whole square. I don't know. Let's see. Let's just multiply them. Maybe this. I don't know if it will work or not. I don't know if it will work or not. So this is beta x minus x squared minus alpha beta plus alpha x. So this is actually integral root under dx by, this is minus alpha beta. So let's form a whole square here first. Minus x squared. Take x out of here. Well, taking x out of here, which is alpha plus beta by 2, obviously have to add a 2, plus, no, this is also minus alpha plus beta by 2 whole square. Now here add that quantity, which is alpha plus beta by 2 whole square. This is actually, so now a whole square is formed, which is minus of x minus alpha plus beta by 2 whole square, and we have to simplify this one. So let's simplify this as alpha plus beta squared by 2 minus alpha beta, which is alpha square, which is actually alpha plus beta squared minus 2 alpha beta by 2, which is actually alpha squared plus beta squared by 2. Okay, this is actually, so root under alpha squared plus beta squared by 2 whole square. Okay, so this again comes out in the form of sine. So yeah, nah, I hope there is something mistake. This is not 2, this is 4. So yeah, this is 4. So this is also 4. So yeah, this is 4 as well. So this is actually alpha minus beta whole square. So this is alpha minus beta whole square by 4. So this is actually not root. This is actually alpha minus beta by 2 whole square minus that quantity. So this is actually sine inverse x minus alpha plus beta by 2 divided by alpha minus beta by 2 plus c. So this is actually sine inverse 2x minus alpha minus beta by alpha minus beta plus c. So this is the answer for the 44th question. Now let's proceed for the question number 45, which is, I hope this is correct, the calculation. So if something is wrong, please let me know in the comment section. Now let's do the 45th question. So the 45th question states integral dx by root under x squared minus x minus 6. So what we can do here is, can be done by solution, which is x minus 2 times x minus 3 times x plus 2 is equal to x minus 3. Yeah, that can be done. Then take this as z squared. So consider out and if I take this as x squared. Okay. So let's first fractionize this one. So this gets fractioned out as x minus 3 times x plus 2, I hope, because x squared plus 2x minus 3x, which is minus x, and minus 6. So now let's take this x minus 3 as z squared. Okay, so dx will become 2z dz and x plus 2 will become z squared plus 5. Okay, so this is integral 2z dz by root under x plus 3 will become z, and this will become root under z square plus 5. Minus 3 and so plus 5. Yeah, it is correct. So z will cancel z, and this is 2 integral dz by root under z square plus 5, and this is actually 2 times. This is actually a standard result. So let's write down the standard result first, which is where should I write? Integral dx by root under x squared plus a squared. This is actually log. This is actually log of x plus root under x squared plus a squared. This is actually yeah. So this becomes root under x, which is z plus root under z square plus 5. So z square plus 5 is actually x plus 2, and z is actually root under x. Wait, z is actually root under x minus 3, and z square plus 5 is x plus 2. So this becomes root under x plus 2 plus c. So this is the answer for the 45th question. Now let's proceed to the 46th question, which is now let's proceed to the 46th question, which is integral log x dx divided by 1 plus log x squared. So for this integral, let's there is a log x. We can do it. So this gives 1 how can we integrate this? So x becomes this is x, which is well, let me think of it. This is actually well, now doing log x is equal to can be written as this equal to Yeah. I hope. So I hope I can solve this. Like log x is equal to u. So e to the power u will become x. And from here you can write it as dx by x is equals to du, and dx will become eu du, e to the power u du. So log x is u times e to the power u du divided by 1 plus u squared. So yeah, this is our equation, and well, I hope I have solved this one. 1 plus x minus 1. I hope I have solved this in this video. So this becomes 1 plus u times e to the power u du. 1 plus u minus 1 e to the power u du divided by 1 plus u squared, which is e to the power u du divided by 1 plus u squared minus integral, there is no square, minus integral e to the power u du divided by 1 plus u squared. So now if we integrate this, becomes 1 by 1 plus u times integral e to the power u du minus ddx of 1 by 1 plus u times integral e to the power u du. Sorry, there is no dx, this is du times du minus e to the power u du by 1 plus u squared. So this becomes e to the power u by 1 plus u minus this is minus 1 by 1 plus u squared. So this is actually, the minus will come out and this will become positive. This is e to the power u, this is e to the power u by 1 plus u whole squared. So this will become integral e to the power u by 1 plus u squared du. I need some space here. Minus integral e to the power u by 1 plus u squared du. So both of them cancels out and your final result becomes e to the power u, let me write, by 1 plus u plus c. So this is your final result. Let me write it here clearly. So this is e to the power u by 1 plus u plus c. And let's substitute u. So I am erasing this portion. So after this line I have written that in over here, and then I am going to substitute u as e to the power log x by 1 plus log x plus c, which is actually x by 1 plus log x plus c. So this is your final answer for the 46th question. Now let's proceed for the 47th question, which is, now let's proceed for the 47th question, which is integral cos of log x dx. So for this question, let's suppose I is equal to this. We are let's suppose that I is equal to integral cos of log x dx. Okay, so let's integrate this by parts. This gives cos x, this gives cos of log x times x, because the first function, let's suppose this be the first function. Wait, let me write. Cos of log x is first function and 1 as second function. Okay, so integrating 1 will give us x, and minus, in differentiating cos of log x will give us minus sine of log x times 1 by x, and integrating 1 will give us x. So this into dx. So x will cancel out x, and this will be x times cos of log x plus integral sine of log x dx. So now for this integral, I am writing in black. Sine of log x I am going to call first function and 1 as the second function. So this will become x cos of log x plus, this will again give x sine of log x minus integral sine of differentiating sine of log x will give us cos of log x times 1 by x times x dx. So as you can see that this becomes cos of log x dx, which was our I. So we can write it as x cos of log x plus x sine of log x minus I. So from this and this, we can just call 2I is equals to x, let's take common x, times cos of log x plus sine of log x, and which implies I is equals to x by 2 cos of log x plus sine of log x plus c. So this is our answer for the 47th question. So let's proceed. Hope I can finish the 100 integrals. Well, it contains some of the limit counting and some of the integral by the definition of definite integrals. So let's proceed. So with 47th, let's do the 48th question, which is integral 2 to the power 3x sine 4x dx. So according to the LIAC rule, the exponential functions comes in last and the trigonometric function comes before exponential. So we are going to have sine 4x as the first function and 2 to the power 3x as the second function. So what we can do is, well, first we have to let this as I. Let I is equal to this integral. So this is our first function and this is our second function. So sine 4x times integral 2 to the power 3x dx minus integral of dx of sine 4x will give us cos 4x by 4 times integral 2 to the power 3x dx times dx. Okay, so just evaluate this function. This is 2 to the power 3x times sine 4x, sine 4x divided by 3 times log 2 minus, take 1/4 out and integrating cos 4x times 2 to the power 3x divided by 3 times log 2 dx. So, well, we can just take out 12 log 2. So let's take out 12 log 2. So this is 2 to the power 3x sine 4x divided by 3 log 2 minus 12 log 2. Now integrate this by parts again, using this as the second function and this as the first function, and this will give cos, this will give cos to the cos 4x by 4 times, integrating this will give 2 to the power 3x by, well, the denominator remains same, the denominator is 12 log 2 minus integral, differentiating this will give a positive of sine 4x divided by 4, and integrating this will give again 2 to the power 3x divided by 12 log 2 dx. Okay, dx. So let's just simplify this. How can we simplify this? Let me see. So this is 2 to the power 3x times sine 4x divided by 3 log 2 minus, this is actually 2 to the power 3x times cos 4x divided by 144 log 2 square, and this is also negative of, did it come with, yeah, so this is actually 48 times 12, I hope. 48 times 12, 48 times 12 is 96, this is 48. So this is actually 576 integral 1 by 576 log 2 square integral of sine 4x times 2 to the power 3x dx. Okay, so I hope this is correct. So as you can see that this function is again I, so we can write it as I plus 1 by 576 log 2 whole square I is equals to, let's write it as 2 to the power 3x by 3 log 2 will give us here sine 4x minus, so this gives us, I hope, 48, so this gives us cos 4x by 48 log 2. Okay, so therefore this is therefore, which implies that I times 576 log 2 square plus 1 by 576 log 2 square is equals to 2 to the power 3x by 3 log 2 times this one, which is sine 4x minus cos 4x by 48 log 2. And now I can just cancel 1 log 2, and what is 576 divided by 3 9s are 27, 50, this gives 192. So that implies I is equals to 192. Sorry, 192 log 2 times 2 to the power 3x divided by. So yeah, seriously, this is quite unnecessary. I don't know. Well, I don't know. This is quite unnatural sum because really this is too much bad looking. I don't know if I differentiate this. Even if this will be, I don't know that. I don't know if it is correct or not. Maybe hope for the best. May this be correct. So now, so this is our 48th question. Let's proceed for the 49th question, which is, let's proceed for the 49th question. Let's proceed for the 49th question. So 49th question is integral of sec cube theta d theta. So this is a very common problem. So what you have to do is you have to sec square theta times sec theta d theta, which is actually take this as second function and this as first function. Okay, so this is actually sec theta times integral sec square theta d theta minus d theta of sec theta times integral sec square theta d theta times d theta. Okay, so this is actually sec theta tan theta minus this is also sec theta tan theta times tan theta d theta, and this is sec theta times tan theta. This is sec theta times tan theta minus this is tan square theta, which can be written as sec square theta minus 1. So this is actually sec theta times sec square theta minus 1 d theta. Oh, sorry. Let I is equals to. Okay. So this gives sec theta tan theta minus integral sec cube theta d theta minus this is plus integral sec theta d theta. So this is actually sec theta tan theta minus, so this is our I, plus log of sec theta plus tan theta. Okay, so implies, or it means 2i is equals to sec theta tan theta plus log of sec theta plus tan theta, and hence I is equals to half times sec theta plus tan theta plus log of sec theta plus tan theta plus c. So this is our 49th question. Let's proceed for the 50th question. And yes, we are halfway done. So let's proceed for the 50th question. The 50th question is root under 2ax minus x squared dx. So this is root under a square minus a square plus 2ax minus x square dx, and this is root under a square minus x minus a whole square dx. Sorry, there is a integration. So this is also standard result, which is x minus a by 2 times a square minus x minus a whole square plus a squared by 2. This is actually sine inverse x minus a by a plus c. So the general formula is that x by 2 times the function which is here plus or minus according to the sign of a squared times, if this was in bottom of dx, then the answer plus c is the general formula. So this is the answer. You can simplify this as x minus a by 2 times root under 2ax minus x squared plus a squared by 2 sine inverse x by a minus 1 plus c. Rather, you can just take that as x minus a by a plus c. So this is our 50th question of the day. Now let's proceed for the 51. Now let's proceed for the 51 question, which is from the page. So let's proceed for the 51st question, which is actually a very simple one, which is let's change the character. So 51 is integral of log x dx. So this is actually integral of log x times 1 dx, which is log x times integral dx minus dx of log x times integral dx times dx. So this is actually x log x minus 1 by x times x dx, which is x log x minus x, which is x times log x minus 1 plus c. And actually, okay. So this is the answer for the integral of log x, integral log x dx. So as of the second question, is 52nd question, which is 52nd question is integral x sin x dx. So take, according to the Liat rule, take x as first function and sin x as second function. So x times integral of sin x dx minus ddx of x times integral of sin x dx, which is minus x cos x. This is plus integral cos x dx, which is sin x minus x cos x plus c. So this is the answer for the 52nd question. Let's proceed for the 53rd question, which is, have you seen the 52nd question? Okay, let's put it, which is x times integral sin x minus ddx of x times integral of sin x dx times dx. So this is minus x cos x, this is plus cos x dx. So this is sin x minus x cos x plus 1. So this is the 52nd question. Okay. So now let's proceed for the 53rd question, which is integral x times sine inverse x by root under 1 minus x squared dx. Okay, so let's substitute x is equals to what? Yeah, let's substitute x is equals to sine. Okay, so that means u is equals to sine inverse x. That means du will be equals to dx by root under 1 minus x squared. So now put it here, which gives this portion will become du, this portion will become du. This is actually u and this is sine u, so this is u times sine u times du. So this is like u times integral sine u du minus du of u integral sine u du times du, which is minus cos u plus integral minus u cos u, minus u cos u plus integral cos u du, which is sine u minus u cos u plus c. So now let's substitute to the original variable. So sine u is x, u is sine inverse x, and what about cos u? So as sine u is equal to x, so x squared plus cos squared u is equals to 1. That implies cos u is equals to root under 1 minus x squared. So this is root under 1 minus x squared plus c. So this is the answer for our 53rd question. Now let's proceed for the 54th question, which is let's proceed for the 54th question, which is integral of log of 1 plus x to the power 1 plus x dx. This is actually integral of 1 plus x, sorry, this is x, times log of 1 plus x dx, because as this is in power, this can come in front. So now just do some bypass here. So this is log of 1 plus x times integral 1 plus x dx minus ddx of log of 1 plus x times integral of 1 plus x squared, integral of 1 plus x dx times dx. So this is actually x plus x squared by 2 times log of 1 plus x minus integral of x plus x squared by 2 divided by 1 plus x dx. So this is actually x plus x squared by 2 times log 1 plus x minus 2 integral x squared plus 2x plus 1 minus 1 by x plus 1 dx. Okay, so this is actually x plus x squared by 2, actually x times x squared by 2 times log of 1 plus x minus half. This is actually x plus 1 whole square, and when we separate, so it will left only 1x plus 1. So it is x plus 1 dx minus integral 1 dx by x plus 1. So this is actually x plus x squared by 2 times log of 1 plus x minus half, this is x squared by 2 plus x minus ln of x plus 1 plus c. So we can write it as that much. So this is actually ln of x plus 1. So let's just separate them. So it will give positive half. So this becomes x plus x squared by 2 plus half times ln of x plus 1 minus x by 2 minus x squared by 4 plus c. So this is our answer for this 54th question. Now let's proceed for the 55th question, which is I'll look at that. Now let's proceed for the 55th question, which is integral of e to the power x sin x dx. So let's use the d. So di method will give sorry, well, don't use the di method here. Let's integrate this by normal method of bypass. It will equal to exponential equal to sin x integral of e to the power x dx minus integral of ddx of ddx of sin x times integral of e to the power x dx times dx, and this becomes e to the power x sin x dx minus this will become cosine of x times e to the power x. So this is e to the power x times cosine of x dx. So this is actually e to the power x sin x dx minus cosine of x integral e to the power x dx plus integral of ddx of cosine of x times integral of e to the power x dx times dx. Well, 55. Let I is equal to this one. So this is actually e to the power x times sin x minus cos x. This is minus actually minus integral sin x e to the power x dx. So this minus comes from the differentiation. This will become minus sin x, and this minus will come out. So this is our I again. So this is again our I. So it can be written as e to the power x sin x minus cos x minus I. So 2i is equal to e to the power x sin x minus cos x implies I is equal to e to the power x by 2 sin x minus cos x plus c. So this is the answer for our 55th question. Now let's proceed for the 56th question, which is so our 56th question is integral of sin to the power 5x dx. So for integrating this, we are going to take sin to the power 4x times sin x dx. Okay, sin to the power 4x can be written as I whole square, so 4. So 1 by 4 times 2 sine square x whole square sine x dx is, am I doing it right? I don't know. Well, why do I do this? Sorry, not here. I don't want to do this. So sine to the power 4x can be written as sine squared x whole square. So that can be written as 1 minus cos square x whole square times sine x dx. So now put cos x as u, so minus sine x dx as du. So sine x dx can be written as minus du. So minus of integral 1 minus q square squared times du can be written as integral 1 minus 2u squared plus u to the power 4 du can be written as minus u plus 2/3 u cube minus 1/5 u to the power 5 plus c, and u was cos x, so minus cos x plus 2/3 cos cube x minus 1/5 cos to the power 5x plus c. So this is the answer of our 56th question. Let's proceed to the 57th question, which is let's proceed to the 57th question, which is integral of tan to the power 5 dx. So in sine's case I have taken out one sine, but in tan's case I will take out a tan square from the tan to the power 5. So this can be written as tan cube x times tan square x dx, which is actually integral of tan cube x times sec square x minus 1 dx, which is integral of tan cube x sec square x dx minus integral of tan cube x dx, which can be again written as tan cube x times sec square x dx minus tan x times sec square x minus 1 dx, which is integral of tan cube x times sec square x dx minus, this is tan x times sec square x dx plus integral of tan x dx. So now this is very easy, so put tan x as u, so sec square x dx will be du, and this becomes integral u cube du minus integral u du, and this can be integrated linearly, which has the answer log of sec x. Actually this is log of sec x. So this is actually u to the power 4 by 4 minus u square by 2 plus ln of sec x plus c. So our u was tan x, so this is tan to the power 4x by 4 minus tan square x by 2 plus ln of sec x plus c. So this is our 57th question. Now let's proceed for the 58th question, which is actually this. So let's proceed for the 58th question. our 58th question is integral of dx divided by 3 sin x minus 4 cos x. So for this, let's do this as this. Take 1 by 5 dx divided by 3 by 5 sin x minus 4 by 5 cos x. So now take 1 by 5 dx by, write this as something like cos alpha sin x minus sin alpha cos x, where you can write tan alpha is equals to 4 by 3. So this is actually 1/5 integral of dx sin x cos 3 minus cos 3. So this is actually sine of what? X minus alpha. Sin a cos b minus cos a sin b. So this is 1/5 integral cosec x minus alpha dx, and this again becomes 1/5 ln of cosec x minus alpha minus cot of x minus alpha plus c, where you can just substitute alpha as tan inverse. So let me write alpha as tan inverse. So you can write it as 1/5 ln of cosec x minus alpha is tan inverse 4/3. So this is tan inverse 4/3 minus cot of x minus tan inverse 4/3. Plus c. So this is our final answer for the question number 48. Let's proceed for the question 49. Sorry, this is 59. Sorry. Let's proceed for question number 59, which is integral sin x dx divided by sin x minus cos x. So for this integral we have a technique, which is write it as sin x minus cos x, and take half first, write sin x minus cos x, leave some gap, and then write the differentiation of this, which is cos x plus sin x. Okay, so now think of sine, for which this divided by the sin x minus cos x times dx. So if we do a plus, then this will become sin 2x, and sin 2x, this 2 and the sin 2x will 2 sin x will cut, and we will get back our previous expression. So this is actually half times integral dx plus integral d of sin x minus cos x divided by sin x minus cos x. So this is actually half times x plus ln of sin x minus cos x plus c. So this is our 59th integral. Let's proceed for our 60th integration, which is actually let's proceed to the 60th integration, which is integral x cube dx divided by x minus 1, x minus 2, x minus 3. So as the highest power on numerator is equal to highest power on denominator, so when we do the partial fractionation we must take a 1. So let's take x cube by x minus 1, x minus 2, x minus 3 is equals to 1 plus 1 by x minus 1 plus a by x plus minus 1 by plus b by x minus 2 plus c by x minus 3. So let's simplify. This gives x minus 1, x minus 2, x minus 3. This becomes x minus 1, x minus 2, x minus 3 plus a times x minus 2, x minus 3 plus b times x minus 1, x minus 3 plus c times x minus 1, x minus 2. c times x minus 1, x minus 2. So this is equal to this. So x cube is equals to x minus 1, x minus 2, x minus 3 plus a times x minus 2, x minus 3 plus b times x minus 1, x minus 3 plus c times x minus 1, x minus 2. So put x is equal to 1 first. This term and this term will cancel out. This term will also cancel out. So this will become a times minus 1 times minus 2. Yeah, is equals to 1. So a will become to half. So let's write as a is equals to half here. Now put x is equal to 2. Put x is equal to 2. So this term and this term will become 0 and b will become b times 1 times minus 1. 2 minus 3 is minus 1. Okay. Is equals to 8. So b is equals to minus 8. Is it? I hope so. B is equals to minus 8. Okay. B is equals to minus 8 and put C. For C would be x is equal to 3. So putting x is equal to 3 will give us this, and this quantity will be 0. X is equal to 3 means this is C times 2 times 1 is equal to 27. C is equal to 27 by 2. 27 by 2. So this is our A, B and C. Now I hope this is correct. So we can just remove that and let's A is equals to half, so this is 1 by 2. B is equals to minus 8, so this is minus 8. And C is equal to 27 by 2, so this is 27 by 2. So now integrating this is x cube by x minus 1 times x minus 2 times x minus 3 times dx is equals to actually integrating dx plus half integrating dx by x minus 1 minus 8 integrating dx by x minus 2 plus 27 by 2 integrating dx by x minus 3, which is actually x plus half ln x minus 1 minus 8 ln x minus 2 plus 27 by 2 ln x minus 3 plus c. So this is our final answer for the integration of this quantity. And now let's proceed to our 61st question, which is actually let's check. So the 61st question is, integral of dx by 1 plus x cube. Wait. So a line to so for this question, let's write it as dx divided by 1 plus x times x squared minus x plus 1. Okay, so let's now partial factorize this one. We don't need to write that in first. So this is actually 1 by 1 plus x squared is equals to, suppose a by 1 plus x cube, a by 1 plus x plus bx plus c divided by x squared minus x plus 1. Okay, so this is actually a times x squared minus x plus 1 plus bx plus c times 1 plus x. Okay, so now this must be equal to 1. Okay, by comparing both sides. So put x is equal to minus 1 first. So yes, is it actually visible? Is it visible actually? I don't know. But let me then change my pen. Let me change my pen. So actually this is what I'm going to write is 1 is equals to a times x squared minus x plus 1 plus bx plus c times 1 plus x. So put x is equals to minus 1 at first. This term will become 0. So a times minus 1 squared minus of minus 1 plus 1 is equals to 1, which is a times 1 plus 1 plus 1 is equals to 1. So a is equals to 1/3. Okay, so write a is equals to 1/3. Now we can just put x is equal to 0. Let's put x is equals to 0. So that means that this b term will go, and this is b times 0 plus c into 1 plus 0. So that this is only c, and this is actually 0 minus 0 will go off, and 0 minus 0 will be 0, and this is actually just plus a. So c plus a is equals to 1. Put x is equal to 0. That means c can be minus of a, which is minus of 1/3. So this is the value of c. Now we have to compare the coefficients of both sides. We can just let's multiply. Let's do it. Comparing coefficients of both sides. Coefficient of x square from both sides. Okay. So x square will come from this a times x square will give a x square, and dx times x will give a x square. No other combination of terms can give x squared, because c won't be in x squared, because c doesn't have a x and here is no term of x squared. So the coefficient of x squared in the right hand side will be a plus b. So a plus b will be the coefficient of x squared in the right hand side, and as you can say that here is no term related x squared, so the coefficient here is 0. Wait, I hope this is wrong. It's actually 1 minus a, isn't it? This is 1 minus a, which is 1 minus 1/3. This is 2/3 actually. Sorry, c is 2/3. So this is b is minus a, which is minus 1/3. So a is 1/3, b is equals to minus 1/3, and c is equals to 2/3. So now we can integrate. This is the 61st question. Now we can integrate. Now integrating dx divided by 1 plus x cube will be integral 1/3 divided by 1 plus x dx plus integral minus 1/3 x plus 2/3 divided by x squared minus x plus 1 dx. Okay, so this is actually 1/3 integral dx by 1 plus x, and this is actually 2/3 minus x by 3, which is 1/3 2 minus x. So this is actually plus 1/3 integral 2 minus x by x squared minus x plus 1 dx. So what we can do now is we can do a lot of things. So from here, why don't we just so this is actually 1/3 ln of 1 plus x plus this will become, we have 2 here. What will differentiating this with this? X squared minus x plus 1 squared dx. This will give 2x minus 1, isn't it? This will give 2x minus 1. So we need to have here 2x minus 1. So let's multiply it with 2. This will give 2x minus 4 by x squared minus x plus 1 dx, and this is actually 1/3 ln 1 plus x minus 1/6 integral 2x minus 1 by x squared minus x plus 1 dx. So there is another minus 3 here, so minus 3, so this will become half integral dx by x squared minus x plus 1, because this is 1/6, that means 3 is on the top and 6 in the below. So if this is minus 3, so minus minus will be positive and 3 will come out of the integration and be half. Okay, so this is actually 1/3 ln 1 plus x minus 1/6 ln x squared minus x plus 1, because this 2x minus 1 is the differential of the denominator. plus this will become half x squared minus x plus 1 will be x squared minus 2 times x half times 2 times half times x plus 1/4 plus 1 minus 1/4. Okay. Plus 1 minus 1/4. So this is actually 3/4. So this is actually integral dx by x minus half whole square, and this is actually plus 3/√3/2 whole square. So this is actually the formula of tan inverse. So this is actually the formula of tan inverse. So this becomes 1/a, which is 2/√3 times tan inverse x minus half by √3/2. So this is actually 2x minus 1/√3. This is actually 2x minus 1/√3. So this is the answer of the 61st question. This is actually 61. So this is the answer of the 61st question. So let's go for the second question, 62. You can just see this one. Let's go for the question number 62, which is question number 62 is here, which is integral dx divided by cos of x minus a cos of x minus b. So this is actually let's take 1 by sine. This is actually sine a minus b, integral sine a minus b. So that means a minus b to x minus b minus x minus a divided by cos of x minus a cos of x minus b dx. Okay, so I have multiplied the numerator and denominator by sine of a minus b, which is a constant quantity, and sine of a minus b can be written as sine of x minus b minus of x minus a. So now let's expand this as sine of a minus b. Expanding this will give you sine x minus b cos x minus a minus sine x minus a cos x minus b dx divided by the cos x minus a cos x minus b. Okay, so now split them up as 1 by sine of a minus b integral. So cos will cut out, and this is going to be tan of x minus b, integral of tan x minus b minus tan of x minus a dx. So this is going to be sine a minus b. Actually this is going to be ln of say x minus b divided by sec x minus a. Let's see, because this integral tan x minus b dx will give ln of sec x minus b, and this minus ln of sec x minus a. So according to the properties of log, ln a minus ln b will be ln a by b. So this is ln of sec x minus b by sec x plus a plus c. So this is our final answer for the 62nd question. So this is the answer. Let's go for the 63rd question. You first write it. If you want, you can check it. Now go for the 63rd question, which is actually, so the 63rd question is sorry. So the 63rd question is integral x cube dx divided by x to the power 4 plus x squared minus 12. So what we have to do is we can do what we can do is this is actually integral of x cube dx divided by x squared squared plus x squared minus 12. So let's put x squared is equals to z. So 2x dx will be dz and 2x cube dx will be z dz. So x cube dx will be z dz divided by 2. Okay. So this is actually half integral z dz divided by z square plus z minus 12. So this is actually half integral, this is 4 minus 3 z dx by x plus 4 times x minus 3 times z plus 4 by in times z minus 3, because this is x square minus 3z plus 4z. This is plus z. So it is correct. And now we can write z as and we have to fractionize this one. So let's fractionize this as z is equals to a times z minus 3 plus b times. Okay. Let us do it manually. Let us like. So let z by z plus 4 times z minus 3 is equals to a by z plus 4 plus b by z minus 3, which is a times z minus 3 plus b times z plus 4 divided by z plus 4 times z minus 3, z by z plus 4 times z minus 3. Okay, so we are very close. We have reached the nearly 37 maths more to go. So let's do it in another color. Let's do it in blue. Is a times z minus 3 plus b times z plus 4 is equals to z. Now put z equals to 3 gives 7b is equals to 3 implies b is equal to 3 by 7 and z is equal to minus 4. So this is minus 7 a is equals to minus Since minus 7a is equals to minus 4 implies a is equals to 4 by 7. Okay, so let's just fractionize this as, let's take the half first. 4 by 7 integral dz by z plus 4 plus 3 by 7 integral dz by z minus 3. So this is actually, let's multiply the half. 4 by 14. So this is actually 2 by 7 ln z plus 4 plus 3 by 14 ln of z minus 3 plus 3. This is 2 7. What is z? Z is x squared. So x squared plus 4 plus 314 ln x squared minus 3 plus. So this is our answer for the 63rd question. Now let's do the 64th question first. So first do the 64th question, then 64. We are reaching our goals. To the 64th question, which is 64 is a good question. Is integral sin x cos x dx divided by a square sin square x plus b square cos square x. Okay. So for this question, let's suppose a square sin square x plus b square cos square x as z. This will give 2a square sin x cos x minus 2b square sin x cos x dx is equals to dz, and sin x cos x dx is equals to dz by 2 times a square minus b square. Okay, so it is rigorously simplified as 1 by 2 a square minus b square integral dz by z. Okay, so this is actually 1 by 2 a square minus b square ln z plus c, which is 1 by 2 a square minus b square ln, what is z? Z is a square sin square x plus b square cos square x. A square sin square x plus b square cos square x plus c. So this is the answer of our 64th question. Now let's proceed to the 65th question, which is this. So the 65th question is integral tan square x sec square x sec to the power 4x dx. Tan square x sec to the power 4x dx. Okay, so this can be written as tan square x times 1 plus tan square x times sec square x dx, and hence it is tan square x plus tan to the power 4x times sec square x dx, and this is actually u square plus u to the power 4 du, where we put tan x is equal to u implies sec square x dx is equal to du, and this is actually u cube by 3 plus u to the power 5 by 5 plus c, where u is tan x, so this is tan cube x by 3 plus 10 to the power 5x by 5 plus c. So this is our 65th question. Now let's proceed for the next question. Let me fill in the marker. Right. So here we go. So now let's proceed to the 66th question, which is I hope you can see the question. I mean, is there a reflection? I don't know. So, well, let's just put the question once more. I hope there is a reflection. What I am doing here is integral of tan square x times 1 plus tan square x times sec square x dx, and then I am just multiplying as u square plus u to the power 4 du, where tan x is equal to u, so sec square x dx will be du. So this is actually u cube by 3 plus u to the power 5 by 5 plus c, which is tan cube x by 3 plus 10 to the power 5x by 5 plus c. So this is the answer for our 65th question. Now I hope this is clear. So this is our 65th question. Now let's proceed to the 66th question, which is integral dx by x cube plus x to the power 4. So for this, let's take dx by x cube x plus 1. Now partial fraction is this, as 1 by x cube times x plus 1 is equals to a by x plus b by x squared plus c by x cube plus d by x plus 1. So this is x cube x plus 1, and this is ax squared plus bx plus, sorry, this is ax squared plus bx plus c times x plus 1 plus dx cube. Okay. Yeah. So that means 1 is equals to ax squared plus bx plus c times x plus 1 plus dx cube. Now put x is equals to minus 1, will give this total term will be 0, and this total term will be 0, and minus 1 cube times d will be 1, which will d is equals to minus 1. Okay, so let's write that somewhere. D is equals to minus 1, and then start comparing coefficients. So comparing coefficients. So coefficient of x cube I'm going to compare. Okay. So coefficient of x cube. Look, x cube will come from x cube will come from ax squared times x, and another x cube will come from bx cube. So coefficient of x cube in the right hand side is a plus b, and in left hand side, as there is no x cube, so the coefficient is 0. So that means a is equals to minus d, which is 1. So this is x cube. So now coefficient. Now first compare the constant terms. So as you can see that the only constant term in the right hand side is c, because c times 1 will only give c, and no other, and as every other term has an x, so there is no constant term. So the constant is c is equal to 1, because in the left hand side the constant is 1. So what is left? The value of b is left. So ax squared bx squared. So now coefficient of x squared is ax squared times 1 will give an x squared, and bx times x will give an x squared. So the coefficient of x squared is a plus b, which is 0, because in the left hand side there is no x squared. So that means b is equals to minus a, which is minus 1. So let's write them. A is equals to 1, b is equals to minus 1, c is equals to 1, d is equals to minus 1. Okay, so now we can just erase them. And this gives integral of 1 by x dx minus integral of x squared plus integral of x cube minus integral of x plus 1. So this is ln x. This is actually plus 1 by x, because it is actually minus 1 by x, but here is a minus, so this will become plus. This is actually minus 1 by 2x squared, I think so. Let me do it. This is x to the power minus 3 dx, so this is x to the power minus 3 plus 1 by minus 3 plus 1. This is minus 2x squared, yeah. So this is minus of ln x plus 1 plus c. So this becomes 1 by x minus 1 by 2x squared plus ln x by x plus 1 plus c. So this is the answer of our 66th question. Now let's proceed for the 67th question, which is 67th question. Let's proceed for our 67th question. The 67th question states to integrate x minus 1 by x minus 3 times x minus 2, x plus 2, sorry, x plus 2. So let's partial fractionalize this one, as this is x minus 1 is equals to a times x plus 2 plus b times x minus 3. Okay, so x is equals to 3, so 5a will become 2, a will become 2 by 5, and x is equals to minus 2, minus 5b will become minus 3, and b will become 3 by 5. So this is actually integral of, this is actually 2/5 integral of x minus 3 dx by x minus 3 plus 3/5 integral of dx by x plus 2. Yeah. So this is actually 2/5 ln x minus 3 plus 3/5 ln x plus 2 plus c. So this is the answer of our 67th question. Now let's proceed for the 68th question. We can do the 68th question here. So the 68th question states that integral dx divided by 3 plus 2 sin x plus cos x is equals to integral of dx divided by, this is 3 plus 2 times 2 tan x by 2 divided by 1 plus tan squared x by 2 plus 1 minus tan squared x by 2 divided by 1 plus tan squared x by 2. This is actually integral of sec square x by 2 dx divided by, we have to calculate this. This is 3 plus tan squared x by 2 plus, sorry, 3 plus 3 tan squared x by 2 plus 4 tan x by 2 plus 4 tan x by 2 plus 1 minus tan squared x by 2. Okay. So this is actually integral of sec squared x by 2 dx divided by 3 tan squared x by 2. Sorry, not 3, this is 2 tan squared x by 2. 2 tan squared x by 2 plus 4 tan x by 2 plus 4, is it right? I hope it is. So this is actually, let's take out half. So this is, so let's assume that tan x by 2 is equals to u. So sec square x by 2 times half times dx will be du, and sec square x by 2 dx will be 2 du. So this is 2 du divided by, this is u squared plus 2u plus 2. So let's this as 1 plus 1. So this is actually integral du by u plus 1 whole square plus 1 square, and well, let me erase this. So I am doing that. So I am doing this as here is equal to, this is 1, so not 1, this is actually tan inverse u plus 1 by 1. No, that's tan inverse x by, yeah, this is tan inverse u plus 1. So this is actually tan inverse, so u star, what is u was tan x by 2, tan x by 2 plus 1. So this is actually the value of this integration. But there's something is mistaken. So what is mistaken here? I don't know. How can I simplify this one? Tan of a minus b. So yeah, it can be written as tan inverse tan x by 2. No, ठीक है, नहीं है शायद. I hope this is the answer. So well, let me check. Times by 2 yeah, this is the correct answer. Oh, let's see.